Hello everyone and welcome back. We are now on Chapter 9, Reducing Project Duration. We have just finished scheduling resources and costs, and we will move on to leadership, teams, outsourcing, monitoring progress, project closure, international projects, and oversight. Reasons for reducing project duration. Time is money. There are always cost-time trade-offs. Reducing the time of a critical activity usually incurs additional direct costs. Cost-time solutions focus on crashing activities on the critical path to shorten the overall duration of the project. Reasons for imposed project duration dates are shown here. Unforeseen delays, incentive contracts, which plays out in construction quite a bit, overhead and public goodwill costs, pressure to move resources to other projects, and other internal organization requests in order to finish a project earlier than planned. Options for accelerating project completion. On the left side, when resources are not constrained, these are options that you have: adding resources, outsourcing project work, scheduling overtime, establishing a core project team, or doing work quickly, kind of laying down the foundation and then coming back to correct it later. When resources are constrained, the options of fast-tracking critical chain, reducing project scope, and compromising quality are other options. So compromising quality, there might be some areas in which the scope can be reduced or quality can be reduced in order to make the work go faster. Types of project costs are project indirect costs that cannot be associated with any particular work package or project activity, and costs that vary or increase with time. And these costs reduce the project time directly. Reducing project time directly reduces the indirect costs. On the other side are project direct costs and normal costs that can be assigned directly to a specific work package or a project activity. So labor, materials, equipment, and subcontractors are options. And crashing activities increases direct costs. So notice, reducing project time directly reduces indirect costs, but reducing project time increases the direct costs. This diagram describes how to identify project costs to reduce project time. Gathering information about direct and indirect costs of specific project durations from within your organization. Searching critical activities for lowest direct cost activities to shorten project duration. Compute total costs for specific durations and compare to benefits of reducing the project time. So there's always an analysis involved when you're attempting to identify and reduce direct costs of your projects to reduce your overall time. The project cost duration graph. On the x-axis we have project duration in units of time, and then the cost on the y-axis in units of some dollar amount. So this chart shows the indirect cost of a project increase over time or as the duration increases, and the direct costs decrease. At some point there is an optimum cost time point, which is shown here as somewhat of an inflection point. So as you're doing your analysis, this is the optimum cost time point that you would want to look for when looking at the optimum project duration. In order to construct a project cost duration graph, these are the steps that you have to follow: finding total direct costs for selected project durations, finding total indirect costs for selected project durations, summing the direct and indirect costs for these selected project durations, and comparing the additional cost alternatives for benefits. So in order to determine activities to shorten, you would want to shorten the activities with the smallest increase in cost per unit of time. Assumptions are that the cost relationship is linear. The normal time assumes low cost, efficient methods to complete the activity, and slope represents a constant cost per unit of time, and so on. But the last point here is all accelerations must occur within the normal and the crash time. So somewhere between the normal time and the crash time. This is an example of a cost duration trade-off table. It shows the activity ID, the slope, which is calculated by crash cost minus the normal cost over the normal time minus the crash time. So that's what that slope number represents. This is showing the maximum crash time, which is simply the normal time minus the crash time. So this slide represents the continuation of the example. This first network diagram shows the normal time. If you look at the chart on the previous page, you would see that A's normal time is 3, B is 6, and so on. The next diagram shows time at 24. So 1 unit of time is taken out of this particular chart. Notice that the X in the diagram means that a activity cannot be crashed or reduced further. So in case of time 24, we've taken a day out of activity A, and once we've done that, we've reached the crash time, which is 2, so it can no longer be crashed. And so the activity network diagram shows that it can complete in a period of 24 time units. The difference in the difference in cost, the total direct cost here, $450, and the initial total direct cost here, $450 again, and now it's gone to $470. So we have increased our cost by 20 based on the slope relationship shown in the table. These other diagrams show continued crashing. So we're now crashing, we moved from activity A, we crashed A, and now we're moving forward to crash, activity D, which was originally at 11 and now it's 10. And so these additional diagrams should show further crashing where you reduce the time and then the costs increase, and so on. So this table shows the project duration from those network diagrams, the direct cost plus the indirect cost of each, and then it shows the total cost. And here at project duration 22 and total cost 775, we have reached that optimum time cost point described in the duration chart. So here it is, showing the optimum duration and the optimum cost as a trade-off of project cost and duration. So these are considerations. You can use the project cost duration graph, use crash times, use the linearity assumption. The cost of activities to crash can be revisited, and time reduction decisions and sensitivity are other considerations. If cost versus the time is not the issue, some commonly used options for cutting costs are reducing project scope, having the project owner take on more responsibility, outsourcing project activities, or even the entire project, or brainstorming cost-saving options. So there are more options than this. It depends on your organization, what type cost-cutting activities that they have within the company. So for your team project, we will discuss how the team project activities could be shortened. Thank you for your attention.